Hi everyone. MINST stands for Modified National Institute of Standards and Technology. This institution provides, among other services, image databases freely distributed for software developers to train their apps. We will focus on digit databases and how to get them. The database we have chosen contains 60,000 images of handwritten digits taken from 250 NIST collaborators and students, and was built to be used in training a computer app to recognize digit images in a process called machine learning. This is what we're talking about here. Developers use these images to train their apps. A lot of zeros. There's much more than that. Ones, two, and so on. Okay? You can find these files in a variety of formats. Let's say binary, CSV, compressed or not. Here they are. If you are a Python programmer, maybe you will choose the binary format because MNIST databases are so popular that some languages have dedicated classes to deal with it. And so does Microsoft, MLNet, CMTK, and third parties like MNIST and Parser. The CSV format can be found here and in other places also. You just have to download them from here, and depending on the source you pick in your computer configuration, it may be necessary to uncompress the GZ file using WinZip, WinRAR, and many others that you can download for free or for a limited time license. Using Notepad to open the uncompressed file, you will get something like this. Each of these records contained 785 elements. The first element, 504, identifies the digit whose image follows. The remaining 784 elements contain a 28 by 28 image. Each array element represents a grayscale pixel and ranges from 0 to 255 value. We use this information here to recreate the image of every one of the 60,000 digits that the file contains. The first 28 elements here represent the first column, the following 28 the second column, and so on. Something like this. The 5 is the digit 5 whose data follows. The next 28 bytes represent the first column data. The second 28 bytes represent the second column, and so on. Using this information, we can recreate the 28 by 28 image that we are showing here. We wrote a very simple program that goes on here. And what this program does is the following. You get the address of the uncompressed file that you got from these sources. This is the address of the uncompressed file you got. The content of the file is represented here, 60,000 records. Well, maybe you don't want that many records to make a test or something like that. So you can do something like this, 100. And you load data. When you say 100 load data, you just have 100 elements here, ranging from 0 to 99. The original information is not classified as the one you see from 0 to 9. No, they come in a random sequence. You can represent the image in dark mode or in black and white mode. Now let's dive into the program to see something about the code. This program is very simple. To load the data, you have this method here. Wait cursor, because 60,000 hacker may take a while. So sometimes it's good to say that the computer is doing something. Indicate that the cursor corresponding cursor here. Now, here we show the number of columns that each hacker has. We know that is 784, but anyway, we're doing it again. Number of rows. This is the number of rows that you've chosen. Let's say you can download the 60,000 images, or you can take just a part of the data. Let's say 100, 200 elements, depending on your purpose. This information here, parse. This parse here takes the field that is comma delimited. So we have on a string. We're going to have a string with the number of rows. Each row here will have this 785 elements, because the first element is the label. So the length of each column, the number of columns is 784. The number of elements in each line is 785, because the first one is the label. We have this loop where we pick all the records we ask it for. This is something like you may or may not find it useful. This is to classify the data you just read in label order from 0 to 9. You may want it or not. And this is to display the figures. We use this variable here, bookmark, to navigate through the database. And draw digit it picks the image you got, the number. It opens an image 28 by 28, initializes pixel value, and here for every data bookmark it picks the label, which is the first byte, and the 784 elements that make the pixel image, and put it here. So this tuple defines the data. And now from this element here, pixels, we are going to construct the image. So row that ranges from 0 to 27, and column, which also runs to 0 from 27. So running through this here, we're parsing the pixels and transforming them in digits and integers, because that's the way the image works. And here, in the following image here, we toggle dark mode. We pick the number we got here, or the complement. The complement to 255, okay? So that makes the difference between dark mode and black and white mode, okay? Then we set the corresponding pixel. That goes on until the image is complete. And here, image, we assign image to the picture box that I have here, and display the image, okay? This is the display of the current row, the bookmark position to navigate, just for you to know where in the database you are. Well, that's almost all there is to talk about. The rest is kind of bureaucratic routines of defining variables and so on. There's nothing special here. So let's get back to the application and see how it works. Switching back and forth dark mode, navigating. And that's all, folks. A copy of this program will be available on GitHub, and I hope you like it. Thank you very much.